So, in this one, we're gonna be basically refactoring our value struct, just to generally improve it and make it a little bit easier to debug and everything else. But the first thing we're gonna do is, right, let me delete this. We're gonna move our value struct into its own file. So we will take this bad boy right here, paste her in here for now. And this bad boy, put that in here. Let's just copy these for now to make our life a little easier. Okay, so first things first, we're actually gonna move our enum type in here. And I'm also gonna replace int and float with number because it's like a scripting line, so it'll make life easier if we have just a number, kind of like JavaScript. And we will do that. Okay, now we need we want a union here. All b equals false. Double equals 0. So if I remember correctly, the way unions work is they have a max size of the biggest type in here, but only one of these can be set at once. So we will then know based on our type variable, which variable we have to look at in here. And this is a more optimal way to do it. You can use variants, but I think they add like extra overhead and allocations and stuff. Like I said originally, like my plan is not to go like crazy with optimizations and stuff like that, but I still want to have something relatively fast, you know. We don't want our code to just be absolutely screwed by bottlenecks and everything else. So yes, here we are. So type void. Let's replace all of those. We'll replace all of our type ints with type number. I'm actually gonna delete this one. And now, so with these ones, we can now just take our what's that, D to value, and then we'll also take a double value. Come back. There we go. A double. We got a bull one. That'll be on B. Okay, now strings we have to handle just a little bit differently, I believe, because of the way they're allocated or handled, however you want to call it. So for this one, we're gonna have to do I believe it's like this. STD, yeah. Then we'll do another one. Oh, that can't. Yeah, like that. I think that's right. Now, because of the strings, we're also going to have to implement copy and move operators. Hmm. I think for these ones, we don't need to use the new operator. We can just do and then this one, I think it's fine. And then what did this give us? This is a function we're going to add after. Type, if it's a number, set to d over string. That looks fine. So for destroy, yeah, I guess we'll do a switch on the type. This is a string. We need to call this function. And then we'll set our type to void. Now, we want a function to essentially allow us to do a kind of like this, so we can just call as and do a simple like cast. So if we want an int, then we'll just call as int. Sorry, we're gonna have a function called as number. And we're gonna cast this to an int here. And if we want a double, we'll just return as number. Then let's just duplicate this a couple of times. If we want a ball, as ball. String, and I'm gonna do one more in here, just in case you kind of wanna. This one might be redundant, just in case you want a copy. Okay. Now let's just duplicate this because we want an is function. Think we can do void like that? Okay. Now, so this like as string and stuff, we're basically just gonna rewrite these for now. Actually, let's just take that. And what we're essentially gonna do, type equal, actually let's just do a switch. There's a ball. Okay. And then it should be fine. This will just proxy that through to iString. Okay. Now we want I also want a ball is string. And we'll just do those. So we need it as number one. I'll just take that. If it's a void, I guess return 0. It's a number, return it. If it's a ball, yep. And if it's a string, yep. Now we want operator, yep. Operator double. I guess we'll also we'll also have is numeric, in which case it can be a number or a ball, because ball is technically a number. And we'll do ball as ball. Is this one correct? Void, false, number. With this one here, part of me feels like you'd probably want to convert the string. We'll see. I might change that in the future. Now, get rid of that one. We're not using that. We can delete those ones. We're gonna add so if it's a ball on the right hand side there's a ball, then we'll just return b equals right hand side dot b. If is string on the right hand side there's a string, yeah, we'll just do that. Now if it's numeric, then we'll do something similar to how JavaScript works. Yeah, it's like that. I'm not sure how big this is. Okay, 0.000001. Yeah. Okay. And then otherwise we'll just return, we'll fall back to a string equal, might be kind of bad, I don't know. Now, I think this is used somewhere, but for now we're just going to delete it. Now we'll work on our operator overloads here. So a lot of these, for example, we'll just change to is numeric. And then basically all we have to do is, rather than as int, we just do as number. So this will handle quite a few things for us already. And then we'll handle yeah, string concatenation. But then also in JavaScript you can do, if you do like 1 plus 2, it outputs, yeah, 12. So I guess we do this. There is a proper way to do this. It's called like type coercion, but I'm not 100% sure how we go about doing that correctly right now. So you couldn't really do minus on strings and an expression. Couldn't really do times, divide. I mean, greater than you could do on a string. Greater than or equal to you could do on a string. And we already have those. And I think that's mainly it for that. I think we got all this right here. Now we can delete value type. Let's see if we can compile. We're not supposed to have initializers here? Oh. Excuse me. Okay, that's weird. So when I was testing this to test my theory, completely separate, this was totally fine, and the code is basically the same. So I don't quite understand what's going on. Is it some code that's calling it, maybe? Wait, hold on. Okay, we fix this one. Okay, it's fine. It's just the initializers, I guess. Now, does it execute correctly? It looks like it. So I don't know why it complains about this. This is a union. Oh, okay. Is that actually fine? Yeah, looks fine. Okay. So now I have one more thing I want to basically do. There's a couple of things. How long are we? We're 20 minutes. Okay. I'm gonna make a util directory and we're gonna make a scope timer. I'm gonna make a struct. We're gonna use chrono. Um, oops. If we do that, and now we will basically scope timer, handle the destruction. We're gonna want basically do that. View seconds is smaller than this. We will output this. Right? I think it is. Else if our milliseconds is smaller, we'll output the milliseconds, otherwise seconds. Apparently with these though, we need to do, I don't know exactly what this does. STD fix. STD set precision. Um, guess we don't need seconds. Just like that. I think that's right. And now let's see. In our main, basically, I want to a parser. We're just gonna do scope timer. Oh, was that, did I do that in? Node.js and then VM execute. Now let's run. Okay. So Alexa, 57 microseconds. Our parser, 72 microseconds. Cogen, 27. Okay, that feels a bit... I think the math is correct. It just feels very fast. And we'll put another one down here. Okay. It's insanely fast. Okay, so now that we have this, I think our next thing, now that we've got a variable math working, I think we said the next thing we were going to do was our for loops. So if we get those bad boys in, then we will be we'll be after the games. So yeah, I'll see you in the next one. But as for now, our value is prepared to allow us to do some like better handling in the future and add more extensions to it. Like if we implement our structs, it will be a lot nicer to work with, easier to debug and stuff. So yes, we'll get to that.